Today, we are diving deep into one of the most devastating things the human body can go through, a major burn. We're going to map out the whole sequence, from that first moment of cell damage all the way to the body-wide collapse it can trigger, and, most importantly, what you, as the nurse, have to do to stop it. Okay, let's get into it.
So right off the bat, I want you to really think about this. You have a patient with a massive burn covering half their body. What's actually going to kill them first? Is it the awful-looking wound on their skin, or is it something much, much bigger happening on the inside? By the time we're done here, you'll see why the answer is, without a doubt, the systemic shock, and how knowing that has to drive every single move you make.
All right, let's start at ground zero, the biologic why. What's really happening in that split second when intense heat hits the skin? This isn't just some surface-level cut. We're talking about the fundamental destruction of tissue.
The main event here is something called protein denaturation. Just think of the proteins in your skin like these complex, perfectly built structures. Well, intense heat literally breaks them apart. It's like melting plastic. The damage is permanent. And it's this initial destruction that kicks off the whole devastating cascade we're about to walk through.
Now this is super interesting. The damage isn't just one big mess. It radiates out like a bullseye. Right in the center, you have the zone of coagulation. That tissue is gone. It's dead, totally unsalvageable. But around that, you have the zone of stasis. It's got decreased blood flow, it's stunned, but, and this is so key, we might be able to save it if we're fast. The outer ring, the zone of hyperemia, is just inflamed and will probably be fine. Our entire battle is really fought in that middle zone.
So here's the crucial pivot point. How does this localized damage, these three zones, not stay local? Well, think of the skin as your body's dam. It holds everything in place. When that dam breaks, it unleashes a body-wide flood.
And here it is. This is the magic number you absolutely have to burn into your brain. The second to burn covers more than 20% of the total body surface area, or TBSA. We've crossed a critical line. This is no longer just a skin problem.
And bam, the dominoes start to fall. The body's own defense system just goes into complete overdrive. It releases this chemical storm that makes your capillaries, not just at the burn site, but everywhere in your body, incredibly leaky.
So let's trace how this builds into the number one killer, burn shock. First, those leaky capillaries just start pouring plasma and fluid out of the blood vessels and into the tissues. This does two disastrous things. One, you get massive swelling or edema. And two, the amount of fluid inside your blood vessels absolutely plummets. When that volume tanks, so does your blood pressure. And pretty soon, your vital organs, like your kidneys and your brain, aren't getting the oxygen they need to function.
Okay, so we get the chaos happening at the cellular level. But what does this actually look like on the patient in front of you? This is where your assessment skills can literally be the difference between life and death.
You've got to be able to classify the burn's depth in a split second. A first-degree burn, that's your basic sunburn. It's pink, it's dry, no blisters. Second degree, now that's the classic blistered burn. It's wet, it's red, and it hurts like crazy because the nerves are exposed. But third degree, that's a whole different animal. It looks dry, leathery, and can be white or even black. That dead tissue is called eschar.
And here is a massive exam clue that trips so many students up. While a second-degree burn is agonizing, a patient with a deep third-degree burn will tell you they feel no pain in the center of it. And why is that? It's because the burn is so deep it has literally fried the nerve endings. So that lack of pain is actually a huge red flag for much, much more serious injury.
Okay, your patient is in crisis. Their body is collapsing. What you do in these first few minutes is absolutely make or break. So what's first? You go right back to your core training, A, B, C, D, E. But for burns, that A for airway becomes terrifyingly urgent. If that patient was in a fire, you have to assume an inhalation injury. You see soot around their nose or their eyebrows are singed. Those are signs their airway is swelling shut. Securing that airway, probably with a tube, before it closes completely is priority number one. It comes before everything else. I had to put this quote right here on the screen because it's just that important. On an exam or even in real life, it is so tempting to see a huge wound and your brain just screams, impaired skin integrity. That's the trap. For a major burn, the priority is never the skin. It is always airway, which is impaired gas exchange, and circulation, which is depleted fluid volume. Now, to fight that massive fluid loss, you have to know how big the burn is, and you need to know fast. That's where the rule of nines comes in. It's a quick and dirty way to estimate the TBSA percentage. That number is going to tell us exactly how many liters of IV fluid we need to start pumping into them to keep their blood pressure from bottoming out.
Okay, one more huge red flag. That hard, leathery eschar from a third-degree burn, it doesn't stretch at all. So as all that fluid we're pumping in starts to cause swelling underneath it, the pressure just builds and builds until it completely cuts off blood flow. It acts just like a tourniquet. This is compartment syndrome, and you have to be constantly checking for pulses and feeling distal to that burn. If you lose a pulse, it is a surgical emergency, period.
All right, we have covered a ton of ground, so let's put it all together. Here's a super fast recap that traces the entire domino effect, from that first spark all the way to our life-saving actions.
Here we go. Heat denatures proteins, which makes the skin barrier fail. If that burn is over 20% TBSA, you get a systemic reaction with widespread leaky capillaries. That leads to a massive fluid shift out of the blood vessels, causing hypovolemic burn shock. The expert nurse immediately ignores the wound and prioritizes airway and circulation, starting aggressive IV fluids to fill the tank back up and save the patient's life. That's the whole story right there.
And we'll end on this thought. Now that you truly understand that the real danger isn't the wound they can see, but the invisible collapse happening inside, how does that change the way you talk to a terrified family? They're looking at the skin, but you are looking at the shock. Helping them understand that bigger picture is such a critical part of your job. You're not just a clinician, you're an advocate and an educator.